Imagine you are standing at the edge of a frozen plain. The temperature is minus 35 degrees Celsius. The sun has not risen in 22 days, and it will not rise again for another 40. You have no GPS, no insulated jacket, no emergency beacon. You have a stone blade, a handful of dried fat, and the people standing beside you. This is not a survival exercise. This is Tuesday, 30,000 years ago, somewhere in what is now southern Russia, and two species of human are both trying to do the same thing. Survive the night. One of them will. One of them will vanish from the earth, and the difference between them will not come down to muscle or bone density or even intelligence in the way we usually measure it. It will come down to something stranger, something that archaeology is only beginning to understand. The Ice Age North was not simply cold. It was neurologically hostile in ways that modern science is only beginning to map. During glacial maximum periods, roughly between 26,000 and 19,000 years ago, large regions of Eurasia plunged into what researchers now call light collapse. Even south of the Arctic Circle, storm systems, ice sheet albedo, and extreme low solar angles could reduce effective daylight to 2 or 3 hours of dim gray twilight. This is not uncomfortable. This is biologically catastrophic. The human brain runs on light signals. The suprachiasmatic nucleus, a tiny cluster of neurons sitting above the optic nerve, uses light to synchronize virtually every biological rhythm in the body. Sleep, hormone release, immune function, emotional regulation, decision-making capacity. Remove the light signal long enough, and these systems begin to decouple. Modern researchers stationed at Antarctic winter bases document what happens next. Irritability spikes within weeks. Motivation collapses. Cognitive flexibility, the ability to adapt thinking to new problems, drops measurably. In extreme cases, something researchers call the winter over syndrome sets in, a kind of psychological blunting where the world feels distant, unreal, and threatening. And these are modern humans, warm, fed, with satellite internet and scheduled resupply flights. Ice Age humans had none of that. They had darkness, cold, hunger, and each other. And somehow, they had to hold it together for months. The question is how? Here is where the story splits. Because during the peak of the last ice age, Homo sapiens were not alone in northern Eurasia. Neanderthals, Homo neanderthalensis, had lived in Europe and Western Asia for over 300,000 years. They were not primitive apes. They were not mindless brutes. They were cold-adapted, intelligent, experienced survivors who had endured multiple glacial cycles before modern humans arrived. Their bodies were extraordinary. Shorter limbs, wider torsos, larger nasal passages to warm, freezing air before it reached the lungs, barrel chests, dense, powerful muscles built for cold climate efficiency. Neanderthal DNA studies, particularly work from researchers at the Max Planck Institute for Evolutionary Anthropology, show clear signatures of cold adaptation genes related to fat metabolism, skin pigmentation, and even circadian rhythm regulation. In other words, Neanderthals had evolved into the Ice Age over hundreds of thousands of years. Their biology was the answer to the cold. Homo sapiens had something different. Homo sapiens had technology, and that difference, subtle at first, would eventually determine which species left descendants alive today. At a site called Rewired in modern-day Ukraine, dated to approximately 15,000 years ago, archaeologists uncovered something that changed how researchers think about Ice Age shelter. 4 dwellings, constructed almost entirely from mammoth bone. Over 150 individual mammoth bones arranged in interlocking patterns, skulls, jawbones, femurs, forming walls capable of supporting insulating hides against winter storms. But it was the hearths that caught researchers' attention. Not just their presence, their positioning. The hearths at Rewired were not placed simply for maximum heat. They were placed to maximize light radius, positioned to reflect off pale bone walls and compressed snow surfaces. This was deliberate. Modern photometry modeling suggests that a small controlled fire, positioned correctly inside one of these shelters, could have maintained stable illumination equivalent to a well-lit modern room. Think about what this means. These humans, without understanding circadian biology, without knowing what a suprachiasmatic nucleus was, had reverse-engineered a solution to the neurological problem of light deprivation. They had built artificial daylight, not because someone told them to, but because the groups who failed to do it did not survive winter, and the groups who discovered it by accident kept doing it, generation after generation, until it was not experimentation anymore. It was knowledge. Neanderthal shelter archaeology tells a different story. Neanderthal sites across Europe, Bruniquel Cave in France, La Ferracie in the Dordogne, Kebara Cave in Israel, show evidence of fire use, intentional burial, and even rudimentary symbolic behavior. This is important. Neanderthals were not helpless, but their shelters show a pattern that researchers find consistently. Neanderthals appear to have used natural features first. Cave entrances, rock overhangs, natural wind breaks. The constructed shelters that do appear in Neanderthal archaeology are simpler, less modular, less evidence of the deliberate light optimization engineering seen at sapiens sites. One interpretation: Neanderthal cold adaptation was so effective biologically that extreme shelter engineering was less critical for their survival. Their body was the technology, which worked until it didn't. Because the problem with biological adaptation is that it is slow. Evolution works across thousands of generations. But climate volatility during the late Ice Age was moving faster than evolution could track. And when the environment shifts faster than your genes can adjust, you need something else. You need culture. At Sungir, Russia approximately 34,000 years ago, archaeologists uncovered burials that stopped the field cold. 2 children buried together, head to head, covered in over 10,000 hand-drilled ivory beads, fox teeth, pendants, carved mammoth ivory spears. The labor required to produce those 10,000 beads has been estimated by experimental archaeologists at over 10,000 hours of skilled work. 10,000 hours. For a burial? For children who would never use them? Why? Modern neuroscience offers a partial answer that has nothing to do with religion or status. Repetitive skilled activity, bead drilling, hide scraping, bone carving, pigment grinding stabilizes dopamine systems during periods of environmental stress. It creates what psychologists call flow states, periods of focused engagement that reduce cortisol, stabilize mood, and maintain cognitive function. In Antarctic winter research, crews who maintain structured, skilled activities show measurably better psychological outcomes than those who don't. Ice Age humans may not have known the word dopamine, but they discovered the function. Beads were not just jewelry. Repetitive production was not just craft. These were mental survival technologies. The carvings on cave walls, the figurines shaped from mammoth ivory, the ochre pressed into hands and blown across stone. Each one was a human mind holding itself together through the long dark. Dolní Věstonice, Czech Republic, approximately 26,000 years ago. One of the most important Ice Age sites ever excavated. Here, researchers found evidence of large-scale communal food storage, specialized tool production, and what appears to be coordinated hunting of megafauna across vast distances. But the detail that rewrites the survival story is this: bone grease processing pits. Hundreds of bones, leg bones, skull fragments systematically crushed and boiled in hide-lined pits to extract the last possible calories from marrow fat. The caloric yield from this process is small relative to the effort required. This is not efficient short-term behavior. It is only rational if you are planning weeks or months ahead. Modern cold physiology research explains why this mattered beyond simple calories. The human brain under thermal stress, when the body is working hard to maintain core temperature, significantly increases its consumption of glucose. Decision-making quality degrades measurably when caloric reserves dropped below threshold levels. The researchers at Dolny Viestonis were not just storing fat. They were storing the neurological capacity to make good decisions. They were storing the ability to plan the next hunt, to navigate the next storm, to evaluate the next risk correctly. In the brutal mathematics of Ice Age survival, cognitive performance was as critical as physical endurance. And they had figured that out 30,000 years before anyone had a word for cognitive performance. In 2021, genetic analysis of clothing, lice parasites that evolved specifically to live in the seams of fitted garments, pushed the origin of sewn clothing back further than the archaeological record alone could confirm. Bone needles appear at sapien sites across Eurasia from approximately 50,000 years ago. Small, precisely shaped, with carefully drilled eyes for threading sinew. The technology seems simple. The consequences were not. Modern thermal engineering research, comparing fitted, multi-layer garment systems against loose, single-hide coverings, shows a dramatic difference in insulation efficiency. Fitted clothing traps multiple layers of still air against the body. It reduces convective heat loss, the constant bleeding of warmth into cold-moving air, by a factor that changes survival mathematics entirely. With effective, fitted clothing, the caloric cost of thermoregulation drops significantly, which means less food required, which means surviving on smaller stored reserves, which means a higher margin of safety against the catastrophic food shortages that killed entire groups in bad winters. Now compare this to Neanderthal material culture. Neanderthal sites contain evidence of hide use, likely some form of body covering, but the bone needles suggesting fitted, sewn, multi-layer systems appear rarely, if at all, in Neanderthal archaeology. One species adapted biologically to survive cold, the other engineered around biology. And here is the critical asymmetry. Biological adaptation is fixed. It adapts you to one specific cold environment. Technological adaptation is modular. You can wear more layers in a worse winter. You can modify the system as conditions change. Homo sapiens were not just surviving the Ice Age. They were building survival systems that could be upgraded. Ice Age winter camps were not randomly located. This seems obvious, but the specificity of the pattern surprises researchers. At site after site across Ice Age Eurasia, from the Don River Basin to the Moravian Corridor, winter camps cluster on south-facing slopes at specific elevations near frozen river corridors, at terrain features that deflect prevailing winds. These were not accidents of convenience. South-facing slopes in northern latitudes receive measurably more solar radiation during winter months. Even without direct sunlight, a south-facing position could add an hour or more of effective twilight, pale, gray, but real. Modern Inuit survival knowledge, documented extensively by anthropologists in the 20th century, shows exactly this logic. Microgeographic knowledge. Which valley stays out of the wind? Which slope holds snow that can be used for shelter? Which frozen river bend indicates thin ice? This knowledge is treated as survival critical, not because any single factor saves your life, but because accumulating small advantages correctly, consistently, across an entire winter is what survival actually looks like. Ice Age humans were not wandering frozen wastelands in search of luck. They were reading survival information written into the landscape. And crucially, they were passing that reading ability on. Geography became memory. Memory became inheritance. And inherited knowledge accumulated across generations into something that begins to look, from our vantage point, like wisdom. No discussion of Ice Age cold survival is complete without the third shadow. In 2010, a finger bone fragment recovered from Denisova cave in the Altai Mountains of Siberia revealed a third human species, the Denisovans, genetically distinct from both Neanderthals and Homo sapiens. Living in one of the coldest, most extreme environments on the planet, what we know about Denisovan biology comes almost entirely from ancient DNA, because their fossils are extraordinarily rare. But what that DNA shows is remarkable. Modern Tibetan populations carry a Denisovan-derived variant of the EPAS1 gene, a gene regulating the body's response to low oxygen at high altitude. This variant is so effective that it appears to have been strongly selected for in Tibetan populations after introgression from Denisovan ancestors. Sherpas, high-altitude survival, one of the most remarkable human physiological adaptations known. It came from Denisovans. And this is not isolated. Analysis of modern populations across Southeast Asia, Papua New Guinea, and the Pacific shows Denisovan DNA contributions to immune function, metabolism, and cold tolerance. The Denisovans are gone as a species, but their solutions to extreme environments survive inside us. 3 human species, each with different strategies, each facing the same hostile world, and the survivors carried pieces of each other forward. There is a concept in evolutionary anthropology called cumulative culture. It refers to the uniquely human ability to take an existing solution, improve it slightly, and pass the improved version forward so that knowledge accumulates across generations faster than any individual could develop it alone. Chimpanzees have culture. They use tools. They pass techniques between individuals. But chimpanzee culture does not cumulate in the same way. Each generation largely rediscovers what the previous generation knew. Human culture compounds, and researchers increasingly argue that Ice Age environmental pressure may have been a key driver of this compounding. Here is the logic. In a stable, warm environment, mistakes are often recoverable. A failed hunt can be followed by another. A poorly chosen campsite can be abandoned. The cost of ignorance is manageable. In an Ice Age polar winter, this changes completely. A mistake made in October might not kill you in October. It might kill you in February. When your stored fat is gone, when the animals have moved, when the storm has lasted 3 weeks. This kind of delayed consequence strongly selects for long planning horizons, for the ability to model future states, for information retention systems that survive beyond individual memory. The first step may have been storytelling. Researchers like Julien Douy at the French National Center for Scientific Research have traced narrative structures in global mythology to origins that predate the migration out of Africa, suggesting that story, as an information preservation technology, is extraordinarily old. Stories are not entertainment. They are data compression. A story about which valley floods in spring carries survival-critical information in a format that can be retold, remembered, and passed to children who were not there. Ice Age winters did not just pressure humans to survive. They pressured humans to remember. And the machinery of human memory, story, ritual, symbol, art may have been forged in the darkness of the long polar night. The disappearance of Neanderthals, completed by approximately 40,000 years ago, remains one of the most debated questions in paleoanthropology. Genocide? Competition? Climate? Disease? The honest answer is probably some combination of all of these, operating differently in different regions over thousands of years. But there is a pattern in the timing that researchers find meaningful. Neanderthal populations began declining sharply during a period of rapid climate oscillation. The Heinrich events, when Ice Age conditions intensified and then partially collapsed in rapid cycles, spanning as little as a few centuries. Rapid, by geological standards, but fast enough that biological adaptation, which requires thousands of generations, could not track it. Homo sapiens, with their modular technological systems, their clothing that could be layered, their shelters that could be rebuilt in new configurations, their food storage strategies that could be scaled, their knowledge networks that could route around local failures, they had flexibility. Biological optimization is powerful in a stable environment. Technological flexibility is powerful in a volatile one. The Ice Age was not stable. And perhaps this is the quiet, uncomfortable answer to why Neanderthals disappeared while Homo sapiens survived. Not because we were smarter in some absolute sense, but because in a volatile world, the species that could change its own software had an advantage over the species whose survival manual was written into its bones. Long polar nights may have forced one of the most important transitions in the history of the human mind. In darkness, survival required cooperation not just of the moment, but across seasons, across years, across generations. In darkness, survival required trust, the willingness to expend effort now for benefits that would only arrive months later, extended to people who might not be alive to see those benefits realized. In darkness, survival required imagination, the cognitive capacity to model a future state that does not yet exist, and to modify behavior in the present to influence that future state. Researchers call this capacity mental time travel, and it may be the deepest cognitive divide between humans and every other species on Earth. The Ice Age winters did not create this capacity from nothing, but they may have been the selective pressure that sharpened it, generation by generation, winter by winter, until imagining the future was not just possible but automatic. We think in futures as naturally as we breathe. We plan for winters we have not yet seen. We build institutions designed to outlast the humans who built them. We store knowledge outside individual lifetimes and call it civilization. And maybe, just maybe, the first version of all of this was a group of humans sitting in a mammoth bone shelter on the frozen Ukrainian steppe. 34 degrees below zero outside. Firelight on bone walls. Children sleeping. Adults awake, drilling beads, telling stories, remembering where they had been, and planning where they would go when the light returned. Not knowing they were inventing the future. Just trying to survive the night. Civilization did not begin in the Fertile Crescent. Not entirely. The agricultural revolution was not a beginning. It was a harvest. The seeds were planted in Ice Age winter camps, where survival depended on thinking 10 months ahead, where the species that built better software outlasted the species that built better bodies, where darkness, paradoxically, may have been the forge that shaped the planning minds that would eventually build everything you see around you. The Neanderthals are gone. The Denisovans are gone. But pieces of both live in us. In the cold tolerance genes running in Tibetan climbers. In the immune variants carried by Pacific Islander populations. In the quiet genetic echoes of species that met our ancestors in the dark and did not survive the encounter, but left something of themselves behind. We are not a single species success story. We are a palimpsest, written over and over and over again, by every human who survived a night that should have killed them. If you want to go deeper into the hidden technologies, the forgotten survival strategies, and the lost stories of the humans who built the world before history began, this is what Prehistoric Shadows is for. Because the greatest prehistoric mysteries are not always about the bones we find. Sometimes they are about the darkness those people survived, and what that darkness made them become.